Okay, here's another video for using the analytical method from Norton to find the position of a mechanism. And we'll do the 4-bar one right here, which is probably the most difficult of the ones, or the one the most time consuming. We started this in class, so hopefully you'll be able to use some of the things that we did in class to make this a little bit more smoother. You'll note that we just copied and pasted things. I'm not sure that was the smartest way to try to approach that, but it's what I had at the moment available to do. Okay, so this we're going to use example, the values for example 401 out of Norton. So I'll just paste those in here. I've grabbed a hold of the equations from the notes, just pasted in here temporarily, just to make things easier. So K1 is D over A. K2 is going to be D over C. So exciting. D divided by C. Great. K3 is equal to the quantity of A squared minus B squared plus C squared plus D squared, all divided by, I'll go the quantity, 2 times A times C. Kaboom. And then K4, might as well do that now. K4 is going to be D over B. And K5 is equal to the quantity of C squared minus A squared minus B squared minus D squared. All of that divided by 2, the quantity, 2 times A times B. Most of the time I will just divide instead of putting the quantity inside there. Let me double check that I got the right values right here. Let's see. It looks like I might have made a mistake. Okay, so I'm just gonna put these in here temporarily and let's see, put values. Nope, I got them correct. Okay, good. Now we go to the A is going to be equal to, something I forgot to do. Let me go back over here and go radians right here. So I'll turn my angle into radians as a convenience. And I'll say that A is equal to the cosine of that minus K1 minus K2 times the cosine, there you go, of cosine of theta 2 plus K3. As a reminder, one of the reasons why I'm doing this is I want to time out how long it should take. Minus 2 times the sine. And also I thought it might be helpful for anyone that was kind of lost the other day or maybe not paying attention. And just to give you an opportunity to see the thing written out. I mean, it's just being methodical, really. I'm sure that you can handle this without having a video, but I decided to make it anyway. I just think it would be a nice thing to have around. And then I can just assign next year to say, hey, watch the damn video. Right here, and then the K4, no, D is what I want right here. That's so much like this other one. I could just modify it, but I won't be lazy. Cosine of theta 2 minus K1 plus K4 times the cosine of theta 2 and then plus K5. Boom. E, that's easy. Minus 2 times sine of theta 2. And then lastly, that looks a lot like that up there. They could have just used B instead of E. That's interesting. And then we have K1, this is for F, K1 plus the quantity K4 plus 1, no, minus 1, okay. Losing focus. Cosine of theta 2, boom, and then plus K5. Well, I got a values. Let me see, based on my previous one, did I get the same thing? Let me look back over here. Move this guy out of the way. Paste values. Everything looks right. Okay. Even with my short attention span. All right, so I don't know about this 4 versus 3. I'm a little concerned. I wonder if I made a mistake, but I think the book does decide to go for 4 before 3. So let me trust it. All right. So 2 times a tan, okay, and the quantity of negative capital B. We'll go plus the first time. Square root of B squared minus 4 times A times C. Close the quantity for square root, close the quantity for the numerator, divided by 2 times A. Close the denominator, close the tangent, boom. Let's see what those are in degrees. Yes, 98 degrees. Let's check it over here. 98 degrees. We got the same thing. That's good news. And then, as you'll recall, we could cheat, come down here, and all we need to do is change that to minus. And you can actually put all those in here to start with. All right, so we go back up to theta 3 here. We have doing all the same things. It's very tempting for me to cheat here, and I will. So, boom. All I need to do is go move that down to there, move that to there, and that to there, and that to there, and I think one more. Boom. Is that true? Is it negative 60? Let's take over here. Negative 60 is what I got previously. All right. And so, cheating again. Control C, Control V. I just changed that to minus. Kaboom. Is that 20 degrees in the previous one? 20 degrees. All right. So I have this thing in here that I check. Let me think. What did I do for this check? I can't even remember. What makes it a check? I think it's because I could find, yes, Okay, so if I were to go back to where we originally got some of our equations, I was able to check and see. Let's see what I did. I went the arc sine. All right, so when we got theta 4, we didn't have to go backwards and do the identical thing. We could have come in and found what using the y things. I know it's the y because I use the sine right here. So I take the sine of all of the okay. So what I've done here is I figure out what this the distance of A is right here, and then I find the distance of so the distance to get to A, and then I find the vertical distance to get to B, and then the difference between them is just going to be the difference of the height of this link of the coupler, and then I do the same thing, and then so I can use that and. Is that true? Yeah. And then I could just use the hypotenuse. B is the hypotenuse right there. So let me walk through. That's looking over here. Let me take the. Hopefully I can do this right away. By the way, the arc sine. Okay, so let me say what I did. I said I took. This is going to be the numerator, and I'm going to take A times the sine of theta 2, and let me subtract out the let's see, it's going to be the quantity C times sine of theta, what I got for theta 4. I hope this works out. It's going to make it look dumb otherwise. Divided by the hypotenuse. And close. Do I need another close? No, I'm enough. Boom. Yeah. So theta 3. Okay, so I didn't get negative here because I think I got my sign conventions wrong right here. So I think it was like adding or subtracting or something along those lines. But I just confirmed right here that I was getting the same thing. Up to here, I probably worked out what those sign conventions were supposed to be with the negative and the negative onto the thing. But hopefully you get the idea of what we were trying to do there. I was really, when I made this, I was making it for myself. I wasn't really making it for students. But I thought perhaps as an assignment, it would be something worthwhile. Because once we have this thing built in, we can now make a 360-degree thing out of it. And that's where it's going to be useful. And then we're going to also use it in the velocity and acceleration, which I think is kind of neat. And we can also add a coupler curve onto the end of it. So that's my reasoning for it. I can hear my wife is coming back from the gym, so you're going to have to, you can actually hear my wife's voice here in a minute. She's going to hear me talking to myself. I'm going to go, what the hell is wrong with you? And so anyway, if I was going to continue on with this, I guess what I did up here, I could just cheat. You don't have to do this confirm thing, I don't think. Maybe you should. Maybe I should tell you that you should. Put it down here. Yep. And you can see, once again, I did something wrong with the negatives onto there, but I get the same thing. So now let me do the plot of this. The dog is getting upset because I think my wife is going out to get the trash can. And so the dog has to get upset. That's just the way things are. A times the cosine of the theta 2, boom, and then equals A times the sine of theta 2. Now you might be wondering why you're doing this assignment. It seems like it's a pretty boring assignment. It seems stupid. Because when I give you, chances are when you go to try to figure, you do set this thing up with your example, when I give you a different problem to do. There's going to be something unintended consequences. There's always are of what your configuration looks like. And you're going to have to overcome that. All right, so for theta, for 04 right here, we can go, and that's just going to be that D right here. Oh, I didn't mean it. D and equal to 0. Right, so that's just the base point here. We could do the same thing here. Just make it 0 because we're always on the horizontal. And then lastly, for B, we could go in either direction, and that could actually be a check if we wanted to. But we'll just go ahead and say equals A plus the sine, plus B times the cosine, there you go, of, well, let's go up to this angle right there. We'll do that one. And similarly equal to that one plus the sine, time B times the sine of this angle. All right, let me see if I got the right thing for my other one. Yes, I did. Okay. And then up here, similarly, we'll add that x direction plus this times the cosine, quiet, of theta 3. Good. And then equal to here plus B times the sine. Did I accidentally just do the sine? Well, the dog is making noise. Here, let's see. Did I do the sine here? Cosine. Let's see if I can get the right answer. 143 and 67. 143 and 67. Okay. So now I'm going to cheat and I will plot this thing out. Boom. And in my, that's my cheating one. Let me drag those over and drag those over. Okay. So here are the two possible configurations. I'll get rid of this stupid chart title. If I want to, I could modify those series names. I'll come up to here and I will format my chart area. I'll get rid of my border. I just don't like those borders. And looking at this, this actually is not too bad right here. I have the same increments. These are all by 20s. Wow, that's good. But I like to just make them, force them to be by 20s. Force this to be by 20s too. And we're golden. So that's the one. And let's see, just to print this out, make it look nicely. I'm recording right now, just so you know. So you can say hi if you want to. Yeah, she didn't want to.
Hi.
There you go. Yeah, so to print this out nice and neatly, I think it'll be big enough. Now you might want to put your name on the top of it here. But we go to print layout here and go to print area, set print area. Come to print right here. And you can see that it's not going to fit. So let's, I'll do it all in here. Let's make this to landscape and force it to fit on one page. And I like to make it horizontal and vertical here. Kaboom, that's not too bad. I think you can read everything on there. All right, so then you could just print this out right here and you've done your homework. So there is the third video, one more to go. And it took me 19 minutes to